Hi everyone! We are going to go over how to solve differential equations with an initial condition. A differential equation is given as dy dx equals an expression with both x and y variables. The main steps for solving a differential equation are 1. Separate the variables. 2. Take the integrals of both sides. 3. Find the antiderivative. 4. Plug in the initial condition. 5. Solve for c. 6. Find the final equation in terms of y equals.
We are going to walk you through two problems using these steps. Here is the first one. We are going to solve for y, giving the equation dy dx equals y squared over x minus 1 with the initial condition x equals 2, y equals 3. The first step is separating the variables. This means the dy's and y's on one side and the dx's and x on the other side. Then we are going to take the integral of both sides. Don't forget about the plus c. Then we plug in the initial condition. Solving for c gives us c equals negative 1/3. We plug c back into the equation. And then solve for y. Our equation comes out to be y equals 1 over 1/3 minus ln absolute value of x minus 1.
In our next example, we are going to solve for y given the equation dy dx is equal to sine x cosine squared x, and the initial condition of when y is equal to 0, x is equal to pi over 2, which is also equal to the point pi over 2 comma 0. So our first step is to separate the variables, so dy's is on one side and all the x components are on the other. Next, you have to take the integral of both sides, and then the integral of dy is just equal to y. Now you have to take the integral of the x side using parts, in which u is equal to cosine squared x, and dv is equal to sine x dx. So du is equal to negative 2 sine x cosine x dx, and v is equal to negative cosine x. And you just plug these into the equation of the integral of u dv is equal to uv minus the integral of v du. This gives us the equation of our integral equaling negative cosine to the third x minus the integral of 2 sine x cosine squared x dx. Which can also be written so that the 2 is outside of the integral sign, meaning that the two integrals on either side of the equation are equal. This allows you to add over the integral, so you have 3 integral sine x cosine squared x dx equals negative cosine to the third x plus c. Don't forget the plus c. And if you just divide over the 3, you get your integral as negative cosine to the third x over 3 plus c. That way, y is equal to negative cosine to the third x divided by 3 plus c. And now all you have to do is plug in your initial condition of pi over 2 comma 0. Because cosine to the third of pi over 2 is equal to 0, you know that your constant is just going to be equal to 0. This means your final equation will just be y equals negative cosine to the third x over 3.